All right, my friends, by now you should be getting some momentum and being able to kind of do these more independently. So let's go ahead and think about this. What is u equal to? It's equal to x, and your a value would equal 3. So your substitution this time would be u, which is x, equaling a, which is 3, secant theta. And if that's the case, then dx would equal 3, and derivative of secant, my friends, is secant theta tangent theta d theta. There we go. All right. Kind of with these problems, you have to promise yourself that it always looks super bad right before it cleans up. So, all right, so what would x squared be? It would be 9 times secant squared theta, and then bring down the minus 9. And don't forget to swap out dx for, in this case, 3 secant theta times tangent theta d theta. All right, let's clean up that radical there. Let's see, the 9 could factor out. You'd be left with secant squared minus 1. What is secant squared minus 1? Oh, it's tangent squared. So you'd be left with the square root of 9 times tangent squared, which would be 3 times tangent theta. All right, and I know I am skipping quite a few steps there, which is pretty naughty. So feel free to kind of like, scratch that out on the side if it's a lot to keep track of, or skip steps like me. Anyway, totally up to you. Okay. All right. All right, my friends, we're left with the integral of secant theta d theta. All right, this seems a little repetitive. Anyway, so we're left with the natural log of the absolute value of secant theta plus tangent theta plus c. And why aren't we done? Well, because our answer is in terms of theta. And they asked us a question all about x. So let's go back up here and see what we can do. All right, so primary relationship. If I divide both sides by 3, I would know that secant of theta is equal to x over 3, which means this part is done. And I can do my little right triangle move again. Let's see, secant, that's 1 over cosine, so this would be hypotenuse over adjacent. A little Pythagorean theorem work. We end up with the square root of x squared minus 9 for that other leg there. And then the tangent of theta would be opposite over adjacent, like so. There we go. Okay, now let's talk about 2 ways your answer could look. It could look like this. This is a version of the correct answer. But my friends, watch out for logarithms because they are naughty, naughty, naughty functions. So your answer also could have looked like this, since you have that common denominator there. Oh man. And I want you to think about a property of logarithms, because your answer could also look all right, this is about to ruin a couple people's math days here. Let's see, not plus, but minus, right? Oh man. I'm going to go ahead and change my constant up here to C1, because since natural log of 3 is a constant, or the opposite of natural log of 3 is a constant, and C1 is a constant, you could merge them together to create a new constant, which is why another version of the correct answer here, watch out, could be that. There we go. Hopefully that makes sense. If you got to here, you totally know what you're doing. And then if this also makes sense, then you are ready for multiple choice problems where they might use properties of logarithms to simplify the answer. All right, my friends, hopefully this makes sense. And if it doesn't, hopefully you'll ask me some questions so we can help you get through your problem set quickly. Take care, everybody.